So welcome to the Crack the Placements channel. Now let us understand the Morris in order traversal. So this Morris in order traversal is a special case which is quite important in the case of placements. So here the time complexity will be O of n, and so that means the time complexity of our solution, that means the in order traversal will be O of n, and the space complexity will be O of 1. So this is the most important thing. So the most optimized in order solution will be Morris in order traversal. Okay, so now let us understand so what is the concept behind this Morris in order traversal. So first so let us consider so some random tree like 1 2 3 and so 4 5 6 and so 7. So here the basic thing what we are going to do means, so as we know that so when we traverse the tree and come till here, so we are using the stack so that we have the reference. So that means we have come from 1 and then we have moved to 2 and then we have so moved to 4. So that means we must have the reference to each and every node so that we can retrace the path. That means after reaching the 4, so we'll check so check whether right child is present or the left child is present, and after that so we'll trace back to 2. So that means we'll pop this 4 out, and after that so we'll trace back to 2 using this particular stack. But in so because of this retracing back, that means the requirement in order to retrace back from the 4 to the 2 and from the 2 to the 1, so we require this stack. But in the Morris traversal what we are going to do means we are going to make use of the threaded binary tree concept. So in the threaded binary tree what we'll do means, as we know that from 4 we have to move to this 2, so we'll create a pointer from this 4 to this 2, and we also know that after reaching this 2 and we have to move to the 5. So that means 4 2 and then 5, and after reaching this particular 5 we have to move to 1 in order to print the thing. So we'll make a pointer to this particular thing. That means we'll move to the leftmost node and then we are going to make a pointer to its parent, and then that means we have created a pointer from 4 to the 2 and 2 is a parent now. So we'll move to the right child of the 2. So and then from that particular 5, so we have created pointer to the 1, so that after traversing from 4 2 and 5 we can directly move on to 1. And after this what we'll do, we'll move on to the right child. So we'll move on to the right child, and then again we'll so move on to this 6, and then we are going to create the pointer to this particular 3. That means from 6 we have created to 3. So now let us so trace how this works. So we were present at 4, and from 4 we went to 2 and then we went to 5, and after that we have created a pointer from 5 to 1, so we moved from 5 to 1. And after that so we have moved to the right subtree, and then we have moved to the leftmost node, and so we have created a that means the link from the leftmost node to its parent. So we have so traversed so from 6 to 3, and then from 3 to 7. So in this way so we have created the links. Now let us understand the basic coding part. So first we require a vector of integers in order to store the in order traversal. So this is clear. So next thing, so here so tree node structure must be clear. So here in this particular tree node that means the node of the tree, so the structure will be like this. So here the left pointer is present, right pointer is present, and then the so val is present. So this is the structure of the tree node. Okay, so now so what I'll do, I'll create a variable named current, so which suggests that we are present on that particular node at the present moment. So here current is going to suggest that, or current is going to point on the node which we are present at that particular time. So let the initially let current point on the root node. Okay, so then I am going to continue this loop until the current is not null. So until the current is not null, I am going to continue this particular loop. Okay, so here let us understand how to code this particular thing. Now let us understand a situation in which 1, 2 and then so 3 is present, and then 4 is present. In this particular case, if the roots left is not present, then what we have to do, so we have to print this one and then we have to move to the right subtree. Okay, so what I am saying, if the roots left is null, in that particular situation I should print 1, because left, parent and right. So this is the order of inorder traversal. If left subtree is not present, then print that parent and move on to the right subtree. So now let us code this code for this particular case. If currents left is equivalent to null, in that particular situation I have to print the parent. In this particular case I have to push back the currents value into the inorder, and then I have to move on to the currents right. That means right I have to traverse to the right subtree. Okay, suppose if the current left is not null. Now let us understand this particular situation. Okay, so now let us consider a situation so in which currents left is so not null. So now so first let us focus on this particular so this particular left subtree. So if here the current is present, if the current's left part is not null, so then what we have to do, so first thing, if we have to move from this 1 to 2, then we must have reference to this 1. So this is mandatory. So hence we already know that this one should be connected with the so wait, I'll create the inorder so traversal directly for a moment. So this so 2, and then so 2 will come, then 5, 1, 3. So I have to connect, I must have a link from this particular 5 to this one, so that after so traversing so this particular subtree and 2, and I have come to 5, I must directly go to this 1 and print this, and then I can go on to the right child. In order to create this link, so what this 5 actually means, so this 5 is the inorder predecessor of this particular 1. That means in this particular inorder sequence, the element which is present previous to this one is called as the inorder predecessor of this one, which is 5. So we have to create a link. So what we have to do, we have to come to the we have to take reference to this current child, and we have to move on to the rightmost node. Okay, now let us do that particular thing. Let us so create a variable named so predecessor, and we have to first we have to move to the this predecessor should point on the currents left. So predecessor should be present here, and predecessor should so predecessor should move on to the rightmost child of this particular left subtree. Okay, so let us do that. So while predecessors, okay, so right, okay, so is not null. Okay, so this is one case, and the other case is that suppose if the link is present in the initial condition, so then what does it mean? That means it has already been traversed. Okay, if this particular one has already been traversed, then we need not have to print this particular okay one again, and just we can move on to the okay right subtree. Okay, so now okay, I'll explain that in detail later on. So first thing, okay, so either the predecessor's right is null, or the predecessor's right which is present, it must not be equal to the current element. In that particular case, spread is equal to predecessors, okay, right. So we have okay traverse to the left. So if the predecessor's right has become null, okay, so if the okay, so I'll okay, so just take the basic example. So 2 and okay, so 3, if the predecessor's right has okay, so here the predecessor is present now. Okay, predecessor is present now. If the predecessor's right is null, then I have to create a link. Okay, that means the predecessor's right should point on the current now. So here the okay, initially current was present here. We have okay traversed okay the rightmost child in order to find the okay, so in order predecessor, and after that we have to create a link. That means the predecessor's right should point on this current. Okay, so predecessor's right should point on to the current, and after pointing on to the current, so we got the reference to this one, then we can move on to the current's left. So hence current is equal to current's left. So we have moved to the current's left now. So this part is cleared. Suppose if the predecessor's right is equivalent to the current, that means the link is already present. So what we have to do in that particular case? So now let us see what we have to do. So it is very simple. So we have to print that particular current's value. That means we have to okay, so push the current's value. That means current has already been traversed. So hence inorder dot okay, so push back, so currents okay data, so currents okay, so value into the okay, so inorder, and after doing that okay, so before that we have to okay remove that particular link. That means we'll okay, so make the predecessor's right to be null. So if the link is already present, then we'll remove that link, and then we'll print that particular element. So this is the basic understanding of that. Okay, so and after doing that okay, and after pushing back, so what we have to do? So what we have done, we have removed the link, we have pushed the element, and after that we can so move to the okay right okay subtree. So and the code will be cleared, the code is completed, and after that I have to return the inorder okay vector. So I'll run the code and I'll okay, so look whether my code is correct or not. Yes, it's working fine. So then okay, so it's not a okay big issue at all. Okay, so now let us submit the code. Yeah, so this code has worked fine, and okay, so this is one of the best solution what we can okay get. So the lead code timing may vary, but okay, so this is going to occupy O of one space, and okay, so without using any kind of stack and okay inbuilt okay, so recursive calls and all. So this is about the Morris inorder traversal. So please subscribe to my channel, and I'm going to solve each and every question which is present in the lead code, and I'm going to make sure that most of the stuffs will be cleared, and the place and you be, and after completing all my videos you become placement ready.